What if the world outside your window vanishes the moment you turn your back? What if your room, your house, your entire city only becomes real when you actually look at it? This sounds like madness, right? Quantum physics says something shocking. There is an experiment called the double slit experiment. It proves that tiny particles like electrons behave differently when someone watches them. When nobody looks, they act like waves spreading out in many directions. When somebody looks, they snap into one place like solid particles. Your attention literally changes how matter behaves. Now think about simulation theory. If our universe is a computer program, then maybe the system saves processing power by only rendering what you see. Everything else stays in a low detail mode until you turn your head. That's exactly how video games work. The game does not waste energy drawing the forest behind you. It waits until you look. What if our reality uses the same trick? Today, we explore the observer effect and what it means for your life. If you're ready to uncover the truth behind our simulated universe, hit like and subscribe to join us on a journey through the mysteries of simulation theory. Let's get started. Simulation theory says our entire existence might be a digital creation. But how would that simulation save energy? A modern video game uses a technique called occlusion culling. The game only renders what the player can see. Rest of the level exists as data but not as visible graphics. This saves massive computing power. Now apply this to our universe. The universe is unimaginably huge. Trillions of galaxies, each with billions of stars. Simulating every atom in real time would require a computer larger than the universe itself. That is inefficient. A smarter simulation would only render what conscious observers are looking at. Everything else would exist as compressed data or mathematical probabilities. This is exactly what quantum mechanics discovered in the early 1900s. Scientists found that light and matter behave like waves until measured. They behave like particles. The act of observation changes the outcome. Albert Einstein refused to believe this. He said God does not play dice. But modern experiments have proven him wrong. The observer effect is real. It has been tested thousands of times in laboratories around the world. And here is the connection to simulation theory. What if the observer effect is not a mystery of physics? What if it is a feature of the simulation, an optimization technique built into the code of reality? The simulation only renders what you see because rendering everything all the time would crash the system. In the next section, we will see why this problem is deeper than most people realize. Here is the real challenge that makes scientists uncomfortable. The observer effect should not exist in a physical universe. Think about a rock sitting in a forest. Common sense says the rock is there whether you look at it or not. It has a definite shape, size, and position. That is how classical physics works. Objects exist independently of observation, but quantum physics destroyed this idea. A double slit experiment, scientists shoot single electrons at a screen with two slits. Nobody measures which slit the electron goes through. It creates a wave interference pattern. That means the electron went through both slits at the same time, like a ghost. When scientists place a detector to see which slit the electron chooses, something strange happens. The interference pattern disappears. The electron acts like a normal particle going through only one slit. The act of watching changed the result. This has been repeated with photons, atoms, and even large molecules like buckyballs. The effect is real. Now here's the problem for simulation theory. If gravity is base physical matter, then observation should not matter. The universe should not care if you are watching, but it does care. Something about consciousness or measurement forces reality to choose one outcome over infinite possibilities. Why would that happen? In a video game, the game engine only renders what the player sees because rendering everything would waste energy. That is a perfect match. The observer effect could be the fingerprint of a simulated universe, an optimization algorithm built into the source code. Challenge is that most physicists refuse to consider this explanation because it sounds too much like science fiction. The evidence is sitting right in front of us. Reality only solidifies when you look. What does that say about the nature of your own existence? Let me take you inside this mind-bending reality. Close your eyes for a moment. Picture your bedroom exactly as you left it this morning. The clothes on the floor, the cup on the desk. Light coming through the window. Now open your eyes. Your bedroom looks exactly as you pictured it. But here is the question. Is your bedroom rendered in full detail while your eyes were closed? Did every dust particle exist with perfect precision? Or did the simulation store your bedroom as a compressed file, a set of probabilities, a low-resolution sketch until you looked again? Imagine you are playing a massive open-world video game. Stand on a hill looking at a distant mountain. The mountain looks detailed, but the game is tricking you. It is using a low-resolution texture until you get closer. As you walk forward, the game loads higher detail. The mountain did not exist as full geometry until you approached it. Your observation caused the mountain to render. Now apply this to your life. When you walk into your kitchen, the simulation loads the kitchen. When you open your fridge, the simulation loads the contents of the fridge. When you look at your hand, the simulation renders every skin cell and fingerprint. But the moment you look away, those details go back into a probability cloud. This is not a metaphor. This is exactly how the double-slit experiment behaves. Unobserved particles exist as waves of probability. Observed particles snap into one definite location. The simulation is saving computing power by only rendering what conscious minds observe. Think about the implications for your daily life. Every time you turn your head, you are essentially telling the simulation to load a new area. Every time you look away, you are telling it to unload that area. Your attention is the render command, your consciousness is the camera, and the universe is the game engine running behind the scenes. Here is where it gets even stranger. Observation creates reality, then what happens when two people look at the same thing? Who gets the real version? And what happens when nobody is looking at all? We will answer that in the climax. Here is the most powerful argument that the observer effect proves simulation theory. In 2015, a team of physicists performed a quantum eraser experiment. They took the double-slit experiment and added a twist. They measured which path the electron took, but then they erased that measurement before anyone saw the result. What happened? The interference pattern came back. The electron forgot it was being watched because the information was deleted. This is huge. It means the electron does not care about being measured in the past. It only cares about whether the information is available to an observer in the present. Reality retroactively changes based on current knowledge. How is that possible in a physical universe? It is not possible. But in a simulation, it makes perfect sense. Simulation only needs to keep track of what conscious observers know. When knowledge is erased, the simulation frees up that memory and returns the electron to wave mode. This is exactly how a computer program handles variables. A variable holds a value while it is needed. When the program no longer needs that variable, it releases the memory. The electron wave is the default state. Particle is the rendered state. Observation is the program allocating memory. The quantum eraser is the program freeing memory. Now consider the biggest question of all. If observation creates reality, then who or what observed the Big Bang? Who was watching when the universe began? According to simulation theory, the answer is simple. The programmers were watching. The simulation booted up with a default render of the early universe, just like a video game. Loads the starting area before the player arrives. The observer effect is not a strange anomaly. It is the most efficient way to run a universe-sized simulation. You are not just living inside a simulation, you are helping to render it with every glance, every look, every moment of attention. Consciousness is not separate from reality. Your consciousness is a tool that the simulation uses to decide what to draw next. That is both terrifying and beautiful. You are a co-creator of everything you see. Let us bring this all together. The observer effect is a proven fact of quantum physics. Particles exist as waves of probability until someone observes them. Then they snap into one definite location. This makes no sense in a classical physical universe, but it makes perfect sense in a simulated universe. A simulation would save computing power by only rendering what conscious beings look at. Everything else remains in a low-detail probability state. The double-slit experiment, the quantum eraser, and decades of research all point to the same conclusion. Reality cares about being watched. Your attention literally changes how matter behaves. This does not mean your life is fake. It means your life runs on a deeper layer of code. Every time you look at something, you are asking the simulation to load that object in full detail. Every time you look away, you are allowing it to save resources. You are not just a passive observer. You are an active participant in rendering reality. The next time you look at a star or a flower or a friend's face, remember that your attention is making that thing real in that moment.
Without you looking, would it even exist? The mystery of the observer effect is still unsolved, but simulation theory offers the most elegant answer we have found so far.
Does your attention create reality? Share your thoughts on the observer effect in the comments below. I read every single one. And if you want to go deeper, watch our video on the simulation argument, which explains why famous philosophers and tech billionaires believe we are likely living in a simulation. If you enjoyed this exploration of simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. If you're ready for more interesting content on the simulation theory, make sure to check out our other videos. Thank you for watching.